Ever feel like calculus is just throwing random formulas at you? You need to know how to differentiate this, you need to know how to differentiate that. But did you ever stop and ask yourselves, why am I doing this? Now, finding the equation of tangents and normals might feel like another thing to memorize, but I assure you, this is going to be your key to unlocking calculus. Now, before you skip ahead or you go to the timestamp where I go through the first example, I want to just make sure that you fully understand what we're doing when we're finding the equation of a tangent. This part here is so important. If you just take the 5 minutes to understand what's going on here, it's going to make the rest of your time doing this topic feel like a breeze. Okay, so a lot of students memorize the steps, but I don't really know what they're doing. So when we talk about finding the equation of a tangent or a normal, here, this little visual over here helps you understand what is going on. If my goal is to find the equation of the tangent that passes through some particular point P, I'm just essentially finding the equation of this line. Now, if you think about it, have you found the equation of the line before? You absolutely have. In the topic linear relationships, in year 9 and in year 10, you dealt with lines like crazy. So if you think about what formula you use that helped you find the equation of the line, it was the point gradient formula. It was the y minus y1 equals to m bracket x minus x1. Okay, so this point gradient formula says that if you have a point that the line passes through, and if you have the gradient of the line, you can substitute it into here, and it will spit out the equation of the line. Okay, now the normal is going to be the line that meets the tangent at 90 degrees. So now I want you to think, what concept can you recall which says that if you have two lines that are perpendicular to each other, what's their relationship? And their relationship is that the product of their gradients is -1. I prefer this form because it says that the gradient is equal to the negative reciprocal of the other. So if we do a little exercise over here, where I'm going to give you the gradient of one line and then you figure out what the gradient is of the other line. So if I say that the gradient of the tangent is 2, the gradient of the normal is going to be the negative reciprocal of that. So if I take the reciprocal of 2, that's going to be 1/2, and then I chuck a negative in the front. Perfect. How about if I had a gradient of -4/3? Okay, if I take the negative reciprocal of that, first of all, the reciprocal is going to be 3/4. If I take a negative of negative, it makes it a positive. And last one, if I have 1/5, then the negative reciprocal is going to be -5. Okay, perfect. Here are going to be a step-by-step process on how to find the equation of a tangent and a normal. Now, this is good at the very beginning when you're first being introduced to the topic to look at the different steps you need to take. But please do not rely on just memorizing the steps. It's important that you understand why you're doing each step so that you're able to replicate it when you don't have this in front of you. So first of all, our number one step is to find y dash, find our derivative. The reason why is because our derivative is also denoted as the gradient function. It's the function that spits out the gradient. The second step is to sub x into y dash to find the gradient. That's right. If that's the gradient function, you need to plug in a particular x value into that derivative so that it spits out the corresponding gradient. And now you want to sub x into the original function y to find the y coordinate. So you can see here that plugging it into y dash spits the gradient because that's the gradient function. Plugging x into y just spits out the y coordinate because that's what the original function does. And now you also want to sub in that point x1, y1 and the gradient m that you found into this point gradient formula to find the equation of the line. And if we just want to find the equation of the normal, you do the same steps as above. However, we're going to use the fact that the gradient of the tangent is equal to the negative reciprocal of the gradient of the normal. Okay, so now we're ready for the checkpoint questions. Let's have a go at example 1. Find the equation of the tangent to the curve y is equal to 3x to the 4 plus x squared minus 1 at -1, 3. Let's just once again visualize what we're doing here. So here I have my curve. Now I'm not drawing it accurately by any means. I'm just drawing some sort of curve so that we have an idea what's going on. Let's say that this point here is negative 1, 3. Okay, so my job is to find the equation of this line. And if I want to use the y minus y1 formula, I need a point, which I have, and then I need the gradient. So the way you find the gradient is you need to find your derivative / your gradient function. So if I differentiate this, we are going to get 12x cubed plus 2x, and then the negative 1 goes away. Lovely. Now, this here is not the gradient. This is the gradient function, meaning if you want to find the exact gradient that exists at this point, negative 1, 3, what you're going to do is you're going to substitute that x coordinate, x equals to negative 1, into the gradient function. So we get y dash equals to 12 times negative 1 cubed plus 2 times negative 1. That's going to give you negative 12 minus 2, or y dash equals to negative 14. Okay, lovely. So now that I know that that gradient is going to be negative 14, I have my point. All I need to do then is just sub it into that point gradient formula. So sub the gradient is negative 14, negative 1, 3 is my point. So we get y minus y1 equals to m bracket x minus x1. You can see that's minus minus. So we get y minus 3 equals to negative 14, x plus 1. Continue to expand and simplify. And now if I add 3 over to the other side, we get negative 11. Perfect. Okay, example 2. Find the equation of the normal to the curve f of x equals to x squared minus 3x plus 2 at x equals to 3. So once again, I'm going to visualize this. So here I've drawn in a tangent at the point x equals to 3. But the question wants me to find the equation of the normal. So the normal is going to be the line that is perpendicular to the tangent. So I'm going to draw one on top, make that 90 degrees. So that means we're trying to find the equation of that line. Okay, so now I think, how do I find the equation of the line? Well, I want that point that it passes through. Notice that we don't have a complete point. All we have is that x is equal to 3. So that means we need to find the corresponding y coordinate. Okay, I'll keep that in mind. Now we also want to find the gradient of this normal, but can't just skip to finding the gradient of the normal. What you have to do is you have to find the gradient of the tangent by using the derivative y dash, and then you take the negative reciprocal of that in order to find the normal. You can't skip a step, you got to do it sequentially. So the very first thing I'm going to do, I'm going to find the derivative. So we get f dash x equals to 2x minus 3. And then I'm going to substitute x equals to 3, that's this point here, into our derivative. So we get f dash of 3 equals 2 times 3 minus 3, which equals to 3. So that means the gradient of the tangent is equal to 3. Now, the question wants us to find the equation of the normal. So that means the gradient of the normal is the negative reciprocal of that, which is negative 1/3. Okay, perfect. Now, if I want to find the equation of the line, I need the gradient and a point. I don't have the full point. I only have the x coordinate. So the way to unlock the y coordinate is you need to substitute that x value into the original function. If you make the mistake of plugging it into your derivative, it's wrong because the derivative spits out the gradient. If you want the y, you have to plug it into the original, the OG. So now we're going to substitute x equals to 3 into f of x. We get f of 3 equals to 3 squared minus 3 times 3 plus 2. That's going to give me 9 minus 9 cancels. We just get 2. So therefore, this passes through the point 3, 2. And now the next step is to find the equation of the line, substitute the gradient, which is negative 1/3, and the point that it passes through into the y minus y1 equals to m bracket x minus x1 formula. Expand and simplify. Example 3, find the gradient of the tangent and normal to the curve y is equal to sine 3x when x equals to pi on 18. Okay, I'm not going to do a diagram anymore. Let's just do these more quickly now because hopefully we have a deeper understanding of what's going on. Now, they just want the gradient. They don't want the equation, so that's less work for us. So the first thing we're going to do is we're going to find the derivative. So if y equals to sine 3x, to differentiate, a trig or a sine, you take the derivative of the angle, that's going to be 3, comes to the front, and then derivative of sine gives you cos. So you get 3 cos 3x. And now we're trying to find the gradient of the tangent at x equals to pi on 18. So if we plug that into the derivative, what you're going to do is you're going to rewrite this exactly the same, but you're going to replace the x with pi on 18. And yes, that 3 and x are combined together like this. They're one, that's what the cos is taking the cos of 3x. So if I were to rewrite this, we're going to get 3 cos 3 times pi on 18 like that. And if you simplify this, you can see 3 on 18 just becomes 1 on 6. So we get the derivative is 3 cos pi on 6, which is an exact value. Remember that cos pi on 6 is the same thing as cos 30. So if you want to find the exact value, that's root 3 on 2. So you get the gradient of the tangent, let me just write it as mt, is equal to 3 root 3 on 2. And now if you want to find the gradient of the normal, you're going to take the negative reciprocal of that, which is negative 2 over 3 root 3. Of course, you can rationalize it as well. Let's just rationalize the denominator times top and bottom by root 3. That's going to give you negative 2 root 3 over 3 times 3, which is 9. Okay, but to be honest, either should be fine. Next, example 4. Find the coordinates of any points on the curve y is equal to x cubed minus 1 where the tangent has a gradient of 12. Okay, now for this one, I will draw out a diagram to help you visualize what is going on over here. So we have a cubic, y is equal to x cubed, and it's being shifted down by 1. Since this one's easier to draw, I will draw it accurately. So it's going to look a little something like this, where there's that horizontal point of inflection at negative 1. Okay, beautiful. Now we're trying to find any coordinates along this entire curve such that the tangent has a gradient of 12. Now let me explain what that might look like. So at this point here, do you agree that the gradient of the tangent is 0? Because that's all cubics have something called a horizontal point of inflection. So at this point when x equals to 0, y dash is 0. And then you can see that as I move along and I increase my x value, it goes steeper and steeper and steeper. At some point in time, I'm going to choose an exact gradient, I'm going to choose an exact x value such that the gradient is equal to 12. My job, so something like this, my job is to figure out what is that x value that corresponds to that gradient. Okay, so let's go ahead and figure out where that is. So what we're going to do first is we're going to find our gradient function. So y dash equals to 3x squared. And so this is where you need to really wrap your head around what is the purpose of the derivative. Normally, in like the previous examples, what we did is we plugged in known x values into here to spit out the gradient. But you can actually do the opposite way, where you can actually put in known gradients into here. So that's going to plug into the y dash, and it will tell you which x value has that gradient. So in this case, I'm going to substitute, or I will say let y dash equal to 12. So that means we get 3x squared equal to 12, x squared equal to 4, or x equals to plus or minus 2. Now this also makes a lot of sense that we have two solutions. Don't forget the plus or minus. So over here, what I've drawn is going to be your first positive solution, and then cubics are symmetrical, like they're odd function. So it's going to have very similar behavior occurring on the negative side. So at negative 2, it is also going to have a gradient of 12. Okay, so now we want to find the point, the coordinates of the points, not just the x. So what we're going to do is we're just going to sub in each of those x's into the original function to spit out the y. So we get 8 minus 1 is 7. If we plug in negative 2, we get negative 8 minus 1, y equals to negative 9. So therefore, 2, 7, and negative 2, negative 9 are going to be your coordinates. Question example 5. Find the coordinates of point Q where the tangent to the curve y is equal to 5x squared minus 3x is parallel to the line 7x minus y plus 3 is equal to 0. Okay, so let's draw out a scenario to visualize what's happening. So we're trying to find the coordinates of Q where the tangent to this curve here, so I'm just going to draw in some parabola. And we have some point Q on that curve, which also lies on the tangent to the curve. And our job is to find its coordinates. And we are also given that it is parallel to this other line, 7x minus y plus 3 is equal to 0. Now, if I draw in that line like this here, 7x minus y plus 3 is equal to 0, these two are parallel. Now, when you have two lines that are parallel to each other, what's their relationship between their gradients? Yes, they are equal. So if the gradients are equal, then if I can find out what this gradient is, that's going to tell me what the gradient of the tangent is, which will hopefully help me determine what are the coordinates of the curve. So first, if I want to find the gradient and you're given the equation, you want to rearrange it until it's in the form of y is equal to mx plus b, where y is the subject, because the gradient is just the thing that's in front of the x. So I can quickly rearrange this by moving y over to the other side. So you get y is equal to 7x plus 3. So therefore, the gradient is equal to 7. So they both have a gradient of 7. Beautiful. So now what I'm going to do is, given that the tangent has a gradient of 7, I'm going to plug that into the derivative to help me figure out what x value does that correspond to. So let's go ahead and find y dash. Y dash equals to 10x minus 3. And then we're going to let y dash equal to a gradient of 7. So we get 10x minus 3 equals to 7. 10x equals to 10. X equals to 1. Perfect. So what that means is that at this point where the gradient is 7, x is equal to 1. And remember, our big picture goal is to find the coordinate of Q. So we have the x. How do we find the y? Well, you plug in that x into the original y function. So that's just going to give us 2. Therefore, Q has coordinates 1, 2. Yeah, so that's it. I really hope you guys enjoyed this video. I really enjoy creating engaging and accessible math content for all. So if there's any other topic that you'd like me to go through, it could be for any year group, please just let me know in the comments and I will get back to you. Thank you so much, guys. I'll see you guys in the next video. Bye.